This is Mr. Martin. In this video, I'm going to finish up section 11.1 for Precalc Honors and then continue on to section 11.2 where we will be calculating some more limits. So before we go on to section 11.2, let's talk about one-sided limits and two-sided limits. So we'll discuss this more later. This is a basic introduction, but we're going to have right-hand limits and we'll have left-hand limits. So if you notice here, this is a little bit different. I have the limit as x approaches c with a little plus here. So this means the limit as x c from the right. Okay, so if we're approaching it from the right, that means we're moving along the graph left. I know this sounds weird, but you'll get the hang of it when we look at some examples. So that's from the pod. And then down here for a left-hand rule, I have the limit as x approaches c from the negative side. So this is the limit as x approaches c from the left. Okay, so we're moving to the right along the graph as we approach some value c, but we're starting from the negative side, so from the left moving to the right. Again, we'll look at some examples of those. So a note here, so now we have three different types of limits. We have the limit as x approaches c, which is going to equal some value L. Then we have the limit as x approaches c from the right and x approaches c from the left. Okay? In order for us to have a limit as x approaches c, there has to be a limit from the right and from the left. Okay, so this is a very important concept here. In order for a limit to exist approaching some value c, the limits from the left and right must be the same. Okay, so again, just a really brief introduction, and we'll talk more about that in a later video. All right, section 11.2. We're going to look at a bunch of different problems and techniques. Anytime you want to pause the video and work these out on your own, feel free. All right, example 1. We cannot use direct substitution because we'll get 0 in the denominator. So I'm going to try factoring and see what happens. Remember to carry along that limit. Carry this part along with you until you're ready to substitute it in. So I'm going to factor the numerator. That's going to be x plus 4 times x minus 2. And then in the denominator, I had x minus 2. So this looks good. These two are going to cancel each other out. So we get rid of that part where we would get 0 in the denominator. And now we can use direct substitution to substitute into what's left. So we get 2 plus 4 or 6. All right. Let's try one more factoring example. This one's a little bit harder. So I've got the limit as x approaches 2 of x minus 2. All right, normally we'll check to make sure that we do or we don't get 0 in the denominator. We're going to get 0 if we substitute in 2. So I'm going to factor this by grouping. So these two terms have an x squared in common. So x squared, I'm left with an x, and I'm left with a 2 over there, and then plus, and then these two terms have a 2 in common, so we'll factor that out. So x minus 2. Alright, and then we'll continue factoring. I have the limit as x approaches 2 of x minus 2 over, so each of these terms has an x minus 2 in it, so I'm going to factor that out, x minus 2. So in this term I'm left with x squared, in this term I'm left with a plus 2. Again, these two are going to cancel each other out, so I'm left with a 1 in the numerator. Now I can direct substitute in, so I have 1 over 2 squared plus 2 is 1 over 6. Alright, so there's a couple of factoring examples. Rationalizing technique. This one's a little bit harder, so make sure you get enough practice with this. So again, we can't substitute 0 in because we'll have 0 in the denominator. So what I'm going to do is I'm going to multiply the numerator and denominator by the square root of x plus 9 plus 3 over the square root of x plus 9 plus 3. So I'm basically multiplying by the conjugate of the numerator. And again, the reason we like conjugates is because we end up with a difference of 2 squares in the numerator. So I've got the limit as x approaches 0. So these two multiplied together is going to be x plus 9. Our inner and outer are going to cancel out. I'd have 3 times square root of x plus 9 minus square root of x plus 9, so those cancel out. And then negative 3 times 3 is minus 9. Alright, and these 9s are going to cancel, plus 9 minus 9. And then in the denominator I have x times square root of x plus 9 plus 3. Alright, so I also have, so these 9s are gone, I have an x in the numerator and denominator, so these are going to cancel also, and I'll just be left with a 1 in the numerator. And now that the x is gone from the denominator, I can use direct substitution, so I'm going to have 1 over the square root of 0 plus 9 plus 3, which is 1 over, so square root of 9 is 3, plus 3 is 6, 1/6. Alright, so I'm going to end this video here. In the next video, we'll take a look at this limit from calculus called the difference quotient, and this is going to be one of the most important concepts that we're going to discuss at the end of the school year here. So, as always, make sure you get your questions answered, and we'll see you in the next video.